Okay, so let me start. Actually, today's lesson we are going to discuss about new thing, that is universal gates. Universal gates. As name implies, the universal gate can be applicable. It can be applied anywhere. So most of the integrated circuits, ICs, are built with universal gates inside that. So universal gate is simply a one gate which can be used to represent all three main logic. All three, not only all three, all four main logic, Norton and or XO. Right? So that is a special gate, a single gate. So as a combination of this, maybe with multiple such gates, you can create other logics. You know, අනෙක් logics හදන්න පුළුවන්. Right? අනෙක් logics හදන්නත් පුළුවන්. And logic එක, or gate එක, or logic එක, not logic එක වගේම XO logic එක. Okay. So when we introduce the universal gates, there's a special need of universal gate because the hardware complexity and the cost of the hardware will be lower in case if you have produced a universal gate, because the complexity of hardware will be little less because only single gate is there. So it is less complex. So easily it can be built. Okay. Then, therefore, it is required to have a single here. So because of the complexity, because of the difficulty, only the logic implementation of this universal gates came to the. Okay, inside IC, if there are only single gate, so that will be nice because easy to understand, less complex, as well as it saves our hardware cost. Okay, the first example is showing how to represent NOT gate using NOR gate. How to represent NOT gate using NOR gate. Right here, actually A and so both inputs. Here there's a gate with okay, there's a okay, you can see both inputs are combined and only one output, one input, one output. So when you input A here, the first input will be A and the second input also, it will be A. Okay, if you send A 0, so let's do this now. If you send 0 from A, මෙතනින් බිඳුව යවුවොත්. එතකොට මේ ඒත් බිඳුවයි, මේ ඒත් බිඳුවයි. O gate එකෙන්, so 0 0 from O gate, what is the value? 0 and 0, if it go through O gate, what is the value? Yes? 0 and 0 through O gate?
0.
Yes, it's 0. Okay, then 0 0 will be 0. But here, what do you have? Here you have a NOT gate. Can you see? Here you have a NOT gate. So that will invert this to 1. 0 0 0 input as 0, so both inputs will be 0. Then the O gate will output 0, but this NOT at the end, because this is NOR gate, no, this NOT at the end will invert that to 1. And 0 ultimately you can say 0 will output 1. 0 will output 1. So that is the NOT behavior. 0 1 when NOT behavior. Well, let's say I'll take the other possibility. The second one is 1. If this is 1, this is also 1, this is also 1, 1 1 in OR gate is 1, and that will be inverted to 0 with this NOT gate. So you can say when you input 1, it's 0. Always it will invert. When you invert the NOR gate, when you combine inputs of the NOR gate, a NOT gate can be created. And you can see here you can see the law. A or A is A, that we have already learned in the Boolean algebra. Then here A or A not. A or A not. Everything not. A or A, everything not will be A not. We discuss here, right? A will be A or A. Then A or A will be A. and A or A not, everything not will be A not. So that is how it behaves, right? That is how it behaves. OR gate will take A or A and produce, and NOT gate will NOR gate will take A or A not, and A not will be there. L not A not will be there. So that is how we produce output. Okay, so then here you can see 0 to 1 and 1 to 0. Other one is also same. If it is 0, let's draw again 0 here, then 0 here, 0 here, AND gate will output 0, but here you have not will invert to 1. And if you input 1 here, then 1 here, 1 here, if both are 1s, AND gate will output 1, but this will invert that to 0. So for 0 it's given 1, for 1 it's given 0, means it's not gate again. Right? Okay. So I hope you have finished write down this section as I have given earlier. Now it's your time. Okay. So please try to create the following. Okay, write as a question. Question. Create the following circuits using no and no and NAND gates. Create the following circuit using no and NAND gates. The first one is AND gate using NAND gate, AND gate using OR gate, sorry, NOR gate. Then OR gate using NAND gate and OR gate using NOR gate. So these 4. Please you will try to create these 4. OR gate using and OR gate using 2 more. XOR gate using NAND gate and XOR gate using NOR gates. Okay, please write down this question and try to answer this. I'll give you 5 minutes. Just write down the question, write down the note, write down the question and try to answer. Within 5 minutes. Answers you can send using WhatsApp, right? Or this one. Making work command WhatsApp to work command. Anything convenient to you. So let me give you a very small help. So let's see how these gates are behaving. And you can use this platform too. Right? You can use this platform. That is logic.ly/demo. Okay. Then let's create this circuit tree. You have 2 inputs, and also let me send the link to you. Okay, here you have 2 inputs, and then so let's say NAND gate, then NAND gate. Then you need an output. You can see when it is 0, it is 1. When it is 1, it is 0. So what you have to do is actually you have to combine these 1 and 2 to a single switch or single input. Then what will happen? If you give 1, it's 0, 0, it's 1, 1, 0, 0, 1, 1, 0, 0, 1, and it inverts that process. Okay, let's try to create AND gate then. So if you want to create AND gate using NAND gate, what's the difference between AND and NAND gates? Put it. And NAND gate difference. What is that? AND gate and NAND gate difference.
We get the opposite answer.
Yes, we get opposite answer. Means whatever you are getting from NAND gate is opposite of AND. What you are getting from or AND gate is opposite of NAND. Okay, so you have the opposite behavior. Then, so think about this. So if you want AND button, here you have AND, but you don't have AND gates, you have only NAND gates. NAND gate will take AND and opposite it. But if you can opposite that again, you see none of the NAND. Because NAND inputs can be combined together and create a NOT gate. No? So if this is AND will not mean AND will and not will mean no jodi not again not will AND will not will. This not to make I may uding adagat not take not. Then we can produce that AND behavior. So let's see. What is the behavior of AND? You know that if there are two inputs and here 0 0 it's 0, 0 1 it's 0, 1 0 it's 0, but 1 1 it's 1. That is AND gate. NAND gate and again NAND gate will create AND gate. Okay, now you have the idea. So let's give a try again. Small try, right? So don't be so try your best to send the answers. Small try. Okay, I think wait. Okay. Right. Let's do that. So let's create something like this. So use this knowledge and try to create this using maybe or using one. So I'll do that as well. This is no, but you need O. But you need O. But you have this. You can create NOT gate from OR gate like this. NOR gate. If you combine both inputs and connect a bulb, that will create here 1 0 0 1 1 0 0 1. So you can see that as well. Okay, now think about OR gate. You need OR gate, but you have only NOR gates. Only NOR gates. This one. NOR is already the opposite of O. NOR is opposite of O. Then what you can do? Then you can combine another NOR because you have created not NOR and opposite that again. Then A or B not again not will be A or B. So similar to that, you can create OR gate using. Okay, now I have given actually. So you have to answer only two things. No, not two things. Sorry, 4 things, including XOR. There are 4 things. Okay, at least do like this, right? Here OR gate 0 0 0 0 1 it's 1 1 0 gain 1 and 1 1 is also 1. Okay, I'll give you a small tip help. So use this, create and see. Are they behaving like AND gate? Are those behaving like OR gate and NOT gate? AND gate, OR gate and NOT gate. So check the behavior. You can also check the truth table if you want here. Select, go to the truth table, you can see it's generated. But don't create all these. Just select one part and get the truth table of that. Sorry. Just you have to select the inputs and output both, right? Input, output also, then go to the truth table and you can see true, false will be true, true will be false. That is the NOT gate. So you can try that also. Here, if you want truth table of this. Yeah. Right. Okay. So let's do the exercise now. Now you can do that. Right. Now you saw the issue, I guess, but because you have to have 2 wires. That is compulsory. Minimum of 2 wires. It can be more than that, but minimum of 2 wires for NAND or NOR gates. Actually, this answer is correct. Let me explain how this is correct. So this one is wrong, right? You can't write like this. You have to show the 2 inputs. Okay, let's go to the note and see how this happens. AND gate using NAND gate. See here, AND gate using NAND gate. AND gate A and B are there. A and B not will come. So when A and B not is coming, so again it's sending as A and B not, A and B not. So both A and B not and A and B not, and is this and not. And according to the Boolean algebra laws, we learn, according to the Boolean algebra laws, according to the Boolean algebra laws that we have learned, so A and B not, A and B not. So if there is a common knot to them, we can distribute that knot, and in between sign, this we have to change. This is O, the mathematical sign එක වෙනස් වෙනවා De Morgan law එකට. So I hope you can remember the De Morgan law. If there is a common knot, you can change the sign and distribute the knot among those. Right? Okay. So let's see this A and B, A and B, A and B, මැද්දේ n එක O කරලා දෙන්නට දෙකක් දෙන්න. එතකොට A and B not, A and B not. A and B not, A and B not is double knot is same. Double knot is same. So you know, according to A and A is A, idempotent law. A and A is A. So according to that, A and B is again A and B, same. So finally, we derived with the Boolean algebra solution A and B is this one. This is how you can create the AND gate. Okay, please write down this. If you have done, it's okay. Otherwise, please write down this. And this is how OR gate is created. And next is showing the OR gate using NOR gate. So please draw all three. In AND gate using OR gate, also this is also, you can see this is NOT gate, and this is B naught, this is A naught, and A naught, B naught, everything naught is A naught naught and B naught naught, that means A and B. So you can create that. That is using De Morgan's law. Right. So here actually I didn't write that A and A here, A and A naught. I didn't write like that, right? So because A and A is A and A naught is A naught. So you can directly write that. Okay, then okay, let's do something like this. Write down another question. Write down another question. Create using NAND gates and NOR gates. Create using NAND gates and NOR gates. There are two examples you can see. Okay, only do these two examples. So try to do these two examples. They are now more complex, not a simple. You will get this kind of question for the examination. Create using NAND gates or NOR gate. You will get this kind of this kind of one for your examination. Therefore, please consider and do this.